How's that sound?
How's the stuff in
All right, so you guys have any specific questions from the practice test? Or
You do number 8 on the practice test.
Number 8?
I mean, not so much the sketching the curve, but to eliminate the parameters to create a
Oh, yeah, okay.
Cartesian equation. And then number 9 after that.
So number 8, if I give you a set of parametric equations with trig functions in them, when I ask you to eliminate the parameter, you should automatically think, maybe there's an identity that's going to be happening here, right? And maybe, now this one I like a lot, and I would. I wish I would have saved this for the test, but too damn bad for me. So part A is you just got to make your table, your T, X, Y table. And you could be normally what I try to do here is I try to pay attention to what the period's going to be, but really I pay attention to the first quadrant especially, and then I do a few into the second and see if there's any patterns that are going to develop in this. And what's the biggest X could be? You could do this. What's the biggest and smallest sine can be? What to what? What can the outputs of sine be? Yeah, well, you know how to graph sine. It goes from -1 to 1, right? Yeah. So if I multiply that by -5, x can go from -5 to 5. Cool, right? So x can only move within -5 to 5. Y can only move within 4 to -4. Cool. And just going in knowing this will help you as you get your outputs. You already know what the furthest and smallest it can be. So if you go back to -5, 4.8, -5, then you know it's probably going to go back to -4.8. It builds and then comes back. We know what sine does. You guys semi with me here? Okay, a little bit. All right, so that's part A. It's not the current question. The current question is for part B. How to eliminate T.
Solve for T?
You could, sure. You could. What's the big problem between these two? As far as how they're defined based on
the
T.
2T.
Yeah, they don't have the same argument inside, right?
Yeah.
You can see that? And that's one of the first things you look for when you're solving an equation, when you're doing general stuff like this, trying to connect two things. How would I make this become something in terms of T? Yeah. So this would be -5 times 2 sine t cosine t. So this is, so x is -10 sine t cosine t. And y is 4 times sine of t. So what's the nice part to this? What's in here that you need to replace? You need to replace sine t, you need to replace cosine t. Well, what's sine t? Y over 4. Kick ass. And of course now, so the minute now, okay, so sine t is y over 4. How do I figure out what cosine t is?
The inverse? Because
Now you draw a triangle.
Oh, yeah, you have to draw a triangle.
Yeah, you can't do an inverse. You could draw a triangle or you could use identities. Yeah. Triangle to me is a little bit more direct, but it doesn't matter which way you go. Or if you draw a little triangle for this dude, this little triangle thing happens so often, you have no idea. You truly don't. But just having this skill is so important. That's why I try to always push you in this direction. So if this is the angle I'm talking about T,
Y is on
yeah, Y is where it should be. That's nice.
Yeah.
And 4, kick ass. And of course for cosine I need the x side. Cool. And of course, what would that be here?
Y squared minus
16.
Right, biggest dude minus the smallest dude, or the smaller dude squared. So now I know cosine t is what?
The square root of 16.
Beautiful. So now you plot that in there. Plot this in there.
And then you're done.
And you're basically done. You got your relationship between x and y. Don't try to resolve for y. If they're interesting shapes, you probably can't solve for y. right? Y normally gives us the shapes. It can be interesting, but not as interesting as hello, wait. You know, that's going to require me to not have a function. I can't solve for Y then. Don't try. Okay, maybe. Of course, just to continue my beautiful streak of mistakes, I think I forgot the 2 on the answer key, but we'll see. Yay! Have you guys tried the practice test out? It sounds like a few of you guys have. Well, let me give you the answer key, all right?
I was going to ask you to do 9. Whoa.
Yeah, good.
Oh, never mind. Never mind. I understand what he's asking for. Except for the second part. Oh, no, never mind.
So real quick, we'll probably do a problem like this. We'll probably do a hyperbola problem. I'm thinking, bless you. So may have a specific hyperbola problem you want to do, or just a hyperbola, or does anybody need to do a hyperbola? Is everybody cool with hyperbolas?
Let's just do one.
Just say it enough. It sounds really weird. True. Well, let's see. Let's start off like this. Let's do one like that. Of course, you know, what's the first step here? How do I know this is a hyperbola?
Because it's got this.
Minus. That's it, right?
And bring the 4 over.
Yeah, divide the 4 down so you get that 1 there that's required. So I like it. So somebody's got a really good suggestion. You got to make this x squared over
1/4.
1/4. So I just want to point something out for if you have a hyperbola that's centered not at 0, 0. All right, just to explain what I did on the answer key if you're looking at it. It's relatively simple. If you can do this, the non-centered ones are equally easy. So what all can you tell me about this? What's going on here? That's why I hate A and B. It kind of sucks. It doesn't really matter. How far am I going to end up going out from the center?
1/4.
Yeah, 1/2. Good. So whatever letter you want to call this, I don't really care. Let's call it B squared. So B is 1/2. Since it's with the x, that's how far I'm going to go in the x direction. So remarkably enough, in the y direction, I'm going to go
2.
2. Cool. So it really doesn't matter if you call it A or B. And what's really nice with hyperbola is how do I find the foci?
That's this.
Yeah.
C squared.
Yeah, it's plus in this case. The equation already has the minus, so the poor little focus equation gets the plus. Right? Plus, it makes more sense for it to be outside. That's why we're opening out. We kind of always wrap around our foci, that thing. All right, so let's see. So C, what would C be? C squared is 4 plus 1/4.
C squared is 1/4.
Yeah, square root of.
2. I don't know.
That'd be 16/4 plus 1/4. So the square root is 17 over 2. Which is roughly whatever the hell, just a little bit over 2. All right, how are we doing so far? I mean, that's the kind of things you can get immediately. Once you get the equation in the right form, whatever the hell you call it, A or B, it doesn't really matter. Right? All that matters is if it's with the x, it's where I'm going to went left and right. With the y, I'm going to go up or down. Hyperbolas you add for the focus, so who cares which one's bigger? Ellipsis, of course, you got to be careful. Don't come up with imaginary foci. That's getting a little bit. We're not into complex geometry. Thankfully, yeah. Blah, 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 blah. So now, to graph this thing,
Draw the box.
you guys already had draw the box, dude. So if my center was not 0, 0, I would just go to wherever my center is and start counting from there instead. So what do you do if it's shifted, right? And how would this be shifted? What would I see?
Plus.
Like, see it. Like,
Yeah, I'd see a y minus h squared, x minus k, or plus k squared, doesn't matter. If it's negative or positive, it tells you left or right. You guys got it with me? Now the ones I gave on the practice test, you have to complete the square to get it to look like that. Completing the square is a really good skill to have in general. So let's see, so I want to start 0, 0 is my center. In the y direction, we're going to go
4.
Or
2.
2. So 2 up. And which way I'm opening, how am I opening? Up or down? Up and down, left or right?
up and down.
Up and down because the y is positive. I like it. So this is going to be a real point there. And there. How far am I going on the x-axis?
1/2.
1/2. So let's see. Let's do 1. Maybe 1/2. So put a little open circle there, because it's not really a point on your graph. And then you make, like making, keeps telling me, make a box. Draw your little, what should we call it? What do you draw out of there? Asymptotes. Cool. And then now here's my real point. Now you just follow the asymptote out. Well, that's a little bit rough start. Too bad for me. All right. Coolness. Of course, you can always check your work. If you plug a 1 in, you should get something around here. Right? So you can check to make sure you're actually headed in the right direction. Cool. So I would do exactly the same way I just did if the center was somewhere else. I would just build a box around that. Cool. Okay. And if this would have been a plus sign, what would have happened?
And the loops.
Yeah, if this would have been a plus sign here, we would have just had that ellipse there. Kick ass. I like that connection, yeah.
Do we have to say what the asymptote is?
Yeah, for me it's okay to draw it, and I think I tried to say what it was on there, and I forgot to shift it, I think. But what would it be here? It's relatively easy to see. You go up to over 1/2, so it'll be 2 over 1/2. Got it. Yeah, let's just make it 4x. And this will be y equals
Negative.
negative 4x. Cool.
So that's a requirement for the test.
To state what the asymptote is? No.
Okay.
That's fine with me. Just draw them in. That's fine. They're your guides. Yes?
What is C used for?
Yeah, you can plot C on there. How do I normally show C? So what is that? Roughly what? What square root of 17 divided by 2?
A little more than 4.
It's got to be around the 2.1, I would think. So then on here, you can just go, now be careful. Especially if this was shifted, you just got to realize it's still a distance. It's just a distance away from the center. So you go up 2.1, down 2.1. If I wanted to make this not as curved, if I wanted to really extend it out, I would take the focus in. If I was the math god, I would just go, and this would become fat. The more you push it, it's like, oh crap. And then you take it away. Yeah, exactly. Remember that old video of the guy getting hit by the cannonball? Have you ever seen that one?
Yeah.
He's like, oh shit. Not my line of work, that's for sure. Okay.
On number 9, how did you get y equals e to the t?
Because I wanted to. The beautiful thing, I love that. The funny thing about parametric equations, and the book kind of makes a point of this, I think I assigned one homework problem at least that talked about this a little bit. There's almost an infinite number of ways you can define any rectangular equation in terms of parametric equations. Now, some of those definitions, like if I define it based on sine, sine, of course, has a maximum and a minimum amount. So you're not going to capture your entire picture most of the time. So one way to do it, I mean, here I've got x equals y squared. So you always have the one way, this is why I asked for two ways. You always have the one you can just say, let y be t, right? So if y is t, what's x?
X is t squared minus 3t.
All right. Now the second way, you're pretty much wide open because they didn't say anything about preserving the domain. That's the idea with a sign can only go so far. What's wrong with what I chose? I chose to let y equal e to the t. Can my y output then be negative, for example, or even 0? No. So that's what I'm giving up there. But then what would x be?
E to the t squared.
The e to the t squared, which is e to the 2t minus 3e to the t. Right? Or what's another way you could do it?
Oh, shizzle, man.
Or shizzle. Is that what you say? What's another way you could do it?
Can you just
Crazy. Oh my god, you're insane. Alright, sine t, x would be sine squared t minus 3 sine t.
Yeah.
Now, it would have been a much more interesting problem if I would have said, and make sure your domain goes from this to this or something, right? That would have been a little more interesting. It would have been a little more restrictive. But really, you're wide open here because they didn't say I want you to get the entire graph. I just said I want you to represent this relationship in any kind of parametric equations that you can think of. Every single one of these would translate to this. But not all of them would have this whole picture. Does that make sense?
So you can let y equal anything as long as there's a t there?
Yeah. As long as y is some function of t. Crazy. Of course, you could also have y be a constant and x have to be the function of t. Why the hell not? Yeah.
I'm lost.
What's up?
I don't get what it's.
So tell me, which one was kind of like our input variable for this, the way it's written? Which one would you plug a number in for? Y. Because if I plug a number for x, it's kind of gross to try to solve it sometimes, right? So if I plug a function of t in for y, I know exactly what x has to be because x is directly related to it.
Okay.
So then plug your favorite function of t in there, right? Or even function, or function.
Could you do log t?
Yeah. Oh my god, you're crazy. So y equals ln, I'm going to do ln first. And x equals ln of t squared minus 3 ln t. Can that 2 come down?
No.
No. That's the correct answer to come up with after that.
But the 3 can go up, can't it?
Totally the 3 can go up. Wherever the 3 goes, you brought it up.
T.
On the t. So what's wrong with this 2?
It's
It's
not
on the-
It's on the whole damn thing. So be really, really careful. That's so stupid easy to do and then screws the whole problem up. Yeah.
The 2 would only come down if there was something next to the T, right? Underneath it.
Yeah, if you had this, that's 2 ln t.
T.
If you have this,
That's
what it
ln t
is.
squared.
Yeah, ln t times ln t, exactly. Well, so it's got to be on the argument for this property to work correct. All right, maybe. Possibly. Not at all.
No, I get it. I'm just
Yeah.
not happy.
Yeah, just.
I'm having a problem with the partial fraction decomposition. I know how to get to basically until you let x equal 0 or things like that. Like I can get all the steps, and then I just get lost in there.
Okay, all right. Let's do a problem like that. Anybody else like to get their quiz back yet? Anybody else?
You didn't even show it. Let's drop this mod.
What?
Nothing.
I know.
I think I might be getting that too.
All right, so you want to see. All right, let's see.
So is it here?
Let's take one out of the book.
Number 25 from 10.7.
Oh yeah, all right, good. I like it.
Maybe he'll leave you alone.
20 minutes. Oh, is this from the book?
What interesting thing you can really put this in something
I don't want to talk about it.
Of course, I would like this problem, but I don't know if any of you
She's
noticed.
taking my math class.
A shortcut.
Well, I mean, pretty much, but when you get, if you get up to math, I don't know, 280, and your instructor gives you a problem like this, and you complain about it, that it's not fair,
Don't you
shut your mouth and walk away, right? What do you do with this? Yeah, grouping. And the only time it would be vaguely difficult or unfair, almost not really, is if you couldn't group this. But if I couldn't group this and I'm telling you it factors, what would you try then? If you can't group this, what's the only method we have to factor something? Synthetic division. Kick ass. And I told you that before, and very often I like to do that where part A, use synthetic division to do this, and then part B is, now do this. Right? But what's really nice about that bottom is, grouping should work, because that's twice as much as that, right? What's good? So how do you factor the bottom?
X plus 2, X minus 2, 2X minus 1.
No?
No.
X squared.
Yeah, x squared.
2x.
Whoa,
2x.
sorry, I skipped a step.
So be careful now, you choose ended up in the wrong place. That's the problem. And then minus 4. I think, or no, you got yours
I
in there.
skipped a step.
You're good.
That's what
X minus 2, X plus 2, and then 2X minus 1.
Yeah.
Kick ass. So this isn't as bad as it could be, right? Why is this nice? What's true at the bottom there?
There's no, whatever the ones with
There's
square.
no repeated parts. There's no degree higher than 1,
Yeah,
right? Those are the parts where you got to be careful. If that was squared,
squid.
I'd have to have A over this plus B over that squared,
Yeah.
right? That's what I do with repeated. If this was x squared plus 2,
Then you'd have to have bx plus c.
bx plus c over that. I like it. Always the degree less. I like it. But it's none of that. So what could I do? This is
That's
nice.
right. ax over
A, B, C.
a over x minus 2.
Yeah.
b
So
over
this
x plus
is equal
2.
to a over x minus 2, b over x plus 2,
b over
c over
2x minus 1.
yes.
And then you do your stuff.
Do your stuff. That's technically the right. So we get 9x squared minus 9x plus 6 equals, what's he going to pick up?
X plus 2,
2x
minus 1.
Yeah, the other stuff
And then b
picks
picks up.
up. The other stuff, and C picks up. The other stuff. Okay. Good Lord.
And then now you can just.
And what method? You can do either method here, but what method is going to get all the way through this time?
Making it something 0.
Yeah, let x equal to whatever makes it 0. I can actually kill every single one of those and leave one alive. So I can solve for A, B, and C each independently, right? Or, again, you could FOIL this out, collect all your x squared stuff together, set that equal to 9, do it from there. Of course, that's where you end up with matrices. Do you want matrices? Because that's how you get matrices. So if I let x equal
2.
2, I'll get 36
Minus 18.
minus 18 is 18
Plus 6.
is
20.
24. And of course, which one's left alive?
The A.
The A part's left alive. And I get
Equals 2.
4 times
3.
3,
12.
12A. A is 2. Kick ass. Is that, do you see that, Jess?
So those canceled out.
Yeah, because that's why we picked 2 so that those would go away. What sucks is I have 3 things to try to solve for. If I can have a way to kill 2 of them for a minute and then bring them back.
So you can let that be x equals 2 for that part, and then let it be something
Yeah,
else.
yeah, exactly. Because x, what's true about x? It's a variable. I can let it be whatever the hell I want it to be.
So then you do -2 probably.
-2, and then you do
1/2.
1/2. Kick ass. Right.
Okay.
Does that make sense? I mean, that's that method. The other method would be,
Oh,
you know,
gosh.
FOIL this thing out,
Yeah, I did that, and it wasn't
It's not pretty.
so forth, and collect all your x squared stuff together. So maybe you have a plus b minus c or something equals 9, blah, blah, blah.
Well, that's a B.
Somebody sat on the board. It was a pumpkin somebody carved, and that's what it looks like. No, it's a b, yeah. That's not what you're going to get, but just if you did, you can imagine you'll have 3 equations that are like this.
And do the 1 plus 3.
Yeah, that's really kind of a crazy way to go. The only time you have to go that way is if there's nothing at all that I can set x equal to that'll actually make it
That's what I
disappear.
was going to ask.
Yeah.
Like,
So this is x squared plus 2. You know, if all of them had no nice values that make them 0, then I pretty much have to do this. I have to do the equating coefficients part.
okay. Will you give us one?
I'm going to probably give you one. Do you think I'm going to give you one like this, maybe?
No.
Maybe. Start us off. And then I'll give you one where
We need to go.
you can use this on one step, but not the whole thing.
So can we do the...
Right? We've done those before. We did like the first step, we did this, and then we brought that stuff over, and then we did the rest of it with equating coefficients. We've done that several times. Right? Yes?
Can we go farther with that then?
Of course, yeah. We can just do this over and over.
Okay.
It's like Ryan said, you can let x be -2. And then you're going to figure out what is. B, because he's the one that's going to still be there, right? The other ones are going to die. And then you can let x equal 1/2. Yeah. So you'll get A, you'll get B, you'll get C. Okay.
Now can you do one of the ones where we do the moving of the shifting? Of the-
Oh, the number 5?
Are you going to go those on the test, or are those going to be bonus?
It would be bonus.
Okay.
But-
Not worry about it.
Officially, it would be bonus, but I want you to understand it's not that. It's not much harder at all. As long as you remember completing the square, right?
Yeah.
If you don't remember that, it's bad because it's used in a lot of places. So you want to know that. So real quick, just for my peace of mind, so you guys remember how to complete the square. So we do the second one. It's a little tiny bit more interesting. So go ahead and drag the x squared over. This is 5b from the practice test.
So you can pull the 9 out, yeah?
Good, you have to. I love
Because
it.
it has to be one.
Completing the square only works if that's a 1 in front. So if it's not a 1, you got to pull that dude out. Leave some room. So what am I going to add here, real quick? I have to put here to make completing the square work.
9.
Yeah, how do you get that?
Take half of 6.
Half of 6, square it. Kick ass. And the minute I put that there,
You got to subtract it from the other side.
well, do the same thing the other side.
Oh yeah, yeah.
Now here's where things get a little bit freaky, but you know, once you see this, it's not that bad. What am I going to add here, of course?
1.
1, half of 2 is 1 squared is still 1.
And then you've got to do 9.
So I actually just added 9, so on the other side I better
Add another 9.
add 9. Cool. Okay, cool.
So you end up with like 4.
So that's where that stuff comes from on the answer key.
So then you just leave that over the top of, so your x squared is now x plus 1 or whatever.
Yeah, so now you have y plus 1 squared, so minus 3 squared. And over here you have 4. Yeah.
Okay.
So what shape would that be?
That'd be a ellipse.
Ellipse.
Yeah, why?
Because of the plus.
Okay, so because of the plus
Different coefficients.
and different coefficients. Good. So the plus has 2 options, circle or ellipse, and of course these have different coefficients, so it's an ellipse. Minus, I don't care what the hell these are doing.
So then you just bring the 9 down below the 4.
Beautiful. So to put this in the right form, you go ahead and put the x term first with that.
4/3.
Y plus 1 squared over 4/9, and then you can figure out what, A and B are, whatever you want to call them. How do you get C squared?
A squared
A
minus
squared.
B squared.
Subtract the big dude minus the small dude, right? Doesn't matter who you call A, who you call B. I always have somebody that gets so stuck on that they get these weird imaginary foci, and then they come up and ask me, how do I graph that? I'm like, I don't know what to tell you. It's just the big dude minus the small dude. And these are squares, right? If you call him an A squared and you call him B squared,
Yeah.
don't square them again, because then your focus looks really weird. Yeah.
I thought usually, like on your second step, how you added 9 twice, I thought you would subtract it.
No, this is on the other side, right? So I added 9 to this side, I better add 9 to that side.
Why am I thinking?
You're thinking if it's all on the same side.
Okay.
If I'm trying to put like a parabola in standard form,
Okay.
if I add 4, I better subtract 4 at the same time.
Yeah.
Right,
Why'd
the
you
whole.
add 9 again? Okay.
Yeah, choose there.
I wasn't here, I'm sorry. Oh my God. You know what?
So then when you write the origin for that, it would just be left 3 and then down 1.
Yeah, the center would be at 3, -1. So actually, let's go ahead and do this all the way up. To graph this thing, I first go to 3, -1, and then I just walk out from there. And I know exactly how far I'm supposed to walk out. So here's 3, -1 is here. It's my center. And then how far on the x-axis, in the x direction, do I want to move?
2,
3. Oh no.
2,
That's got to be a 4 there, right?
2.
2. So I go up 2,
Mm-hmm.
back 2. It's supposed to be a 1 there. Maybe RHF. And then in the y direction, I want to go up and down 2/3. Kick ass, right? So just because the center is moved, who cares? That's where you start. That's where you. It's like your new origin. Like that's where you originate. You go up 2/3, so almost to 0. Down 2/3, so almost to -2. And then you draw. You're fantastic. My answer key. Yeah, look at that. I did better there. Answer key. It is a potato. That's what I wrote.
Or foci is.
Potato.
Okay.
And the foci. What do you ever see? Square or whatever that is.
Yeah.
About 1.9.
1.9, good. So it's right where it's supposed to be. It's supposed to be inside. That's why that turns back on itself. If I pulled it outside suddenly, it would go, and it would become a hyperbola.
And it's on your y, or quote-unquote y-axis, essentially.
It's always on the major
on the
axis.
major axis.
Major
Yeah.
axis.
So whichever one's bigger.
Whichever one's bigger. Exactly.
So if it were flipped, like,
So it'd be 1.9 or 3.
If these were just in the opposite place, right, if I flipped the coefficients, this would just, of course, be like that, and the foci would be right where they are. They would turn with it.
yeah.
They'll always be on the major axis, the longer axis. Of course, if you have a circle, you don't have foci. They both go and become the center. I like it.
That's not too bad.
Did it.
But just to make sure you can't do, on 3, you can't do C.
Yeah, definitely not.
Oh, but you can do B. I mean D.
Which one? D?
D.
Totally. Yeah, adding, subtracting is easy. The dimensions have to be
The same.
exactly the same. Multiplying
It's different.
is a little weird. You gotta have the inner ones. And there was a homework problem I really liked that said, if you had A, B, you can do this and you can also do this. They both exist. What must be true about the matrices?
They have to-
So if A is m by n, B would have to be
N
by
N.
N.
n by m. So then, right now the n's match. Well, if I turn them around, this would be n by m by n. The m's match. So if one's 3 by 4, the other one would have to be 4 by 3. And then it wouldn't matter which way you did it. Cool. It's still not commutative because your answer would totally be different, right?
Completely.
Yeah.
Here the answer would be how big?
N by N. Oh.
n by m. And here, of course, it would be
N by
N by
N.
n by n. Not the best letters to use for verbal answers. What was that? M as in Mary. Yeah.
Can you do 56 on 11.1?
It's that word problem one, isn't it?
Oh, yeah.
British.
Were you able to do 54?
Which one was that one?
No, I just drew the thing.
It doesn't matter. They both end up being the same, to be honest. So if you want to look at 56, that's the one with uglier numbers.
I don't think that was on. What
Oh,
was it?
hey. It's dead Stewie. I didn't notice.
It's down the office.
They killed Stewie. You bastards. Mixing the two. Let's see. So we got. Blow this up a little bit. Here's 200 inches there. And overstating the thickness here. 3.79 inches there. This is obviously exactly the scale. And the focus is there, which means that this distance here is how much? Become right. Become right. Oh, so it is a little bit different. Who is that, Alexis? It's a little bit different because it doesn't go all the way to the back edge, right? There's a thickness here, so it's a little bit different than 54. Yeah, good. So the actual the surface is here, right? So this would be what this is my parabola part. This is what math would see as the graph of the equation. So this is P. Well, it still works out the same way. I don't know why I'm making a big deal. I guess there is a little bit of weirdness here. No, I guess not. It's all right. I'm trying to figure out if they meant something else other than what it looks like. I don't think they did. It's the same thing. Yeah, it's the same thing. I see. So it's not this. That would make it a different problem. That's my bad. So they say from here up 3.79 inches. Yeah, they make it really clear on there. That's what they mean. Alright, if that would have been the whole thing, it would have been a little bit strange, because then it wouldn't directly relate to my function. It would have this little extra thickness piece to it. If you don't quite understand what I'm trying to say, don't worry about it. It's not as bad as I thought it was. So this just looks weird. Now, the first thing you realize is that if you understand that, then you're halfway there. If you don't know that, then you can't even start. You're 0% of the way there. But I know now that I'm trying to figure out what P is. I don't have an equation.
Mm-hmm.
That sucks. But I do know the general equation for this would be what?
4P equals 200. Oh,
Plus y squared. Oh, okay.
So this is parabolic, right?
Mm-hmm.
Plus is in that section.
Yeah.
It's kind of a giveaway. What does the 200 relate to? You got to be careful.
X squared.
No. No.
Yeah.
So here's the other half of this. Now that I know I got to figure out P, I want to somehow solve this for P. They gave me this for some reason, so it can't be that. Is this the right place to be the focal diameter?
No.
I'd have to know what it is straight across from there, right?
Yeah.
Mm-hmm.
And I don't think that you have to figure that out. That's crazy. So what you can do is, what point is this? What can I consider this point to be?
The vertex.
It is the vertex, but I can consider it to be 0, 0.
Mm-hmm.
And that's the first thing to get over. The only things they told me from the problem were distances. So I can put my origin wherever the hell I want to, as long as it preserves those distances. Now, where is the easiest place to put it? Where it would normally be for the freaking parabola, right? Right at this vertex. So then what point is this?
Negative 200.
No, negative 100.
Good. This is 200 all the way across. This will be negative 100,
Comma 3.79.
3.79. Kick ass.
And on the opposite, 100.
Exactly, 100, exactly, and it's squared, so that's why it can go either way. So how do you think you solve for p?
Plug the point in.
Plug the point in. Solve for p. So the first big hurdle in this problem was to realize it's p that you're trying to get. And the second one is realizing that you can define points. And that's really weird to just be allowed to do that. But I can put my coordinate system down wherever the hell I want to, however I want to. Nah. And of course it preserves the it preserves the distances on that. That's what's important, right? So that point, that distance across does translate directly into a point, which I can throw into this equation, kick ass. Okay, all right.
Is Dem-Waba's theorem the same thing we've been doing?
Oh yeah, that's just the name for R to the N, that kind of thing, yeah. I didn't use the name on the quiz or whatever it was because I knew that would freak people out. Like, what the hell's that? The Waba's theorem. What the hell?
Unless they did the homework.
Huh?
Unless they did the homework.
Well, then you're not freaking out about anything, except your grade.
Just saying. If you'd done the homework, you'd known that.
Shit, man. You're just putting everyone on blast today.
Especially him.
What's better? Well, yeah, I mean that's a generally known fact, but it's up to you. If you don't want to do homework, it's completely your right. Sort of.
Well, it is college.
Yeah, exactly. So I appreciate that you're here because you didn't have to be. I appreciate that. You guys is it hard thinking?
Can we
Do you guys have
another-
Wednesday class?
No.
We don't, but do you guys?
I had one, but
I want to
you
make
can't
sure
do it.
about this because somebody in my other class said,
Yeah.
"Do we not have class at all on Wednesdays?" No, I don't have that kind of control. It's just my own class is not going to meet Wednesday. If you have other classes on Wednesday, you want to be sure if you're having class or not, because some teachers do really important stuff on Wednesday right before Thanksgiving. For some damn reason. Same people that make you have these little tiny note cards full of like 8,000 formulas, right? They're just laughing at you. And you're trying to see it. Yes?
Can you do another one like number 7 on the practice stuff? Can we just practice it,
Okay.
please?
So, you know, I'm kind of limited. I don't know if you guys realize this. If you started to realize most of the complex numbers I'm giving you, some of them are not like this, but most of them look like 5 plus 5i, root 3 minus I, you know. And why do they look like that? Why are they multiples of that situation? Because I'm trying to make angles that you know.
Yeah.
Right? So you don't have to. So two things. So I keep in your head what the hell those angles are, so you don't have to use your calculator to do it. Right? So I don't know. Let's see if we do. What is it, John? 7 minus 7 rad 3i. Or shall we? I don't want to do it to the say third power, fourth power, maybe fourth power.
27th.
All right, we'll do 4.
Dear Lord.
I'll leave the 280th power for the test.
Sweet.
If I ever did that, you know they have 1 plus 1i in there. What's the first step to do then? Here.
Find your R.
Yeah, you could pull out the 7. There's a few different ways you can find this r. So you could say it's 7 times the square root of 1 squared plus square root of 3 squared.
Or you could just say
Or you can just do it directly.
7.
7 squared plus 7 root 3 squared. It doesn't matter. You're going to end up in the same place. But you can pull 7 out here, right? Kick ass. Either way you want to do it. So we get r is square root of 49 plus
49 times 3.
Yeah.
147.
It's 196 there. So I check it out. Okay. And then real quick, 4 comes out of there at least, right? So I can write this as 2 rad, whatever that is, divided by 4. So 49?
Yeah.
That's what we just came from.
So it's 2. Wouldn't it be 14?
14.
So it's a total of 14.
There you go.
No.
No.
It
Equals 14.
It's 2 times 4.
The square root of 49 is 7. So 7 times 2 is 14.
Someday I'll. So, and then of course the only other piece I need is theta. And of course this is where this comes into play. What goes on top?
B array.
So
So
the
negative 7 root 3 over 7.
Yeah, good. Negative rad 3. What quadrant are we in, by the way? This is why I always ask you to graph this thing first. I'm trying to make sure you realize what quadrant you're in.
4.
Yeah, so this one we're going to be in the 4th quadrant.
So rad 3, that's
So what I always remember about tangent, tangent's like sine, because sine's on the top of it. So sine is going to be bigger. Where's sine bigger? Pi over 6 or pi over 3?
pi over
5 or 6.
3.
3.
So this will be some kind of, so this would come out to negative pi over 3.
which is also 5 pi over 3. 5 pi over 3.
Yeah, or you can make it over 5 pi over 3. Now here's why I would use this one over that one, because I know I'm going to multiply by something. And if I use the smaller angle option, the negative one, it's going to keep it within 0 to 2 pi automatically. I'm not going to make a subtract or revolution off mistake. I don't know if you guys follow me on that.
Yeah.
Doesn't matter which one you use. That's all I'll say. Okay. So I'm going to use that one, just because I'm weird. So what do I get for R?
You get 14
14.
14
times cosine. No,
cosine.
Pi over
since you're
3,
using negative,
pi.
Which one?
negative pi over 3.
Of course, cosine and negative is cosine of the thing, right? Or then plus I sine of negative pi over 3, but again, that's just a minus on the outside, right?
Yeah.
So some of you guys I noticed like to do that. That's cool. That's perfect. That's much better actually. But or use 5 pi over 3 directly. It's not going to hurt anything or anybody because it's the same damn angle, right?
Yep.
Backwards or forwards.
But then it's
And that's it.
5.
That's a little bit easier with multiple, right? So what's r to the 4th?
14 to the 4th times cosine 4.
It's 38,416.
Okay.
Cool. 4 pi over 3.
No, that was outside is.
Yeah, I know. I'm figuring 4 pi over 3 is not equal to that. But that's cool, right? You just multiply by 4 the angles. And then, of course, what quadrant is 4 pi over 3 in? 3rd quadrant. So both of these are going to be
Negative.
negative, so that's going to become a
Negative.
positive. Good. You guys with me? 3rd quadrant.
Say that one more time.
So since this is the 3rd quadrant, that answer is going to be negative. And so is this one, but there's already a negative there.
So they're both
Cool.
positive.
So what is cosine of 4 pi over 3? It's close. It's almost blah.
Oh, right. 3 over. Oh, no.
Yes, almost.
Negative 1/2.
Negative 1/2. I think that's what you said, Karen. I couldn't hear you. Negative 1/2 plus. So that one must be the other one.
I.
Rad 3 over 2. Oh, all right. And then you can distribute that if you want to.
You want us to, though,
Yeah,
yeah.
how do you want that on the step?
You wanted
It's
us
not too bad. You can do 14 to the 4th, and then take half of it. That's all good. So what was? Well, that's good. Take half of the whatever the hell this number is.
It was 38,416 divided by 2. 19,208. Yeah, there you go.
And then plus 19,208 rad 3i. Is that cool? Just distribute that through. Bang. And if you realize you can just throw this into your calculator and have it check your work for you, that kicks ass too. Yes, sir.
I got lost at the part of the equation where you went to R4, like how did you get cosine 4 pi?
So in general, if R is, Z is R, I'm going to say R there, it's too bad for us. Z is R cosine theta plus I sine theta. Z to the nth will be R to the nth cosine n theta plus I sine.
That's it.
That is something you need to
I
know.
thought it was,
And then when you
I think I
multiply.
was thinking of the 2 pi k one for some reason.
Again, yeah, that's when it asks you to find the roots, not the
This
power.
is, okay.
Yeah.
I keep doing
Sick.
So if you did it with 5 pi, you'd get what, 20 pi over 3, and then it'd just be like 6 rotations with one more and then a little bit of
The
that.
20 pi over 3.
Yeah.
Yeah.
You can keep it 20 pi over 3.
It would actually come out to be 2 pi over 3 there, right? But why do you not care? Because cosine doesn't care. And it would be plus 2 pi over 3.
What?
No?
Don't be
Wouldn't it,
bringing me back to any Tales from the Dark Side thing I've watched before.
wouldn't it be
Little
5?
creature's going to come out of there.
No, yeah.
Okay,
Wouldn't it?
I get it.
It wouldn't be 4 pi. Wouldn't it still simplify down to 4 pi? If you had 20 pi over 3, it'd still simplify down, yeah.
20 pi over 3.
Uh-huh.
Maybe it was, let's see. Minus, so 6 rotations would be 18 pi over 3 is 2 pi over 3.
Oh, okay.
And the reason that's okay, and again, this is all, I chose to go the way where I ended with a minus sign there, and then it canceled with the sign of 4 pi over 3. Now, what's the sign of 2 pi over 3? It's going to be positive, right? If it has a plus sign there and the sign of 2 pi over 3, it's still going to come out to be plus. So that's why both ways jive. So you can either use the negative angle there or the actual, between 0 and 2 pi angle. I don't care. And I'm telling you that it's very often easier to do this one. You don't make a rotation mistake, subtracting revolutions off mistake, if you do that way. All right. I have nothing myself for today.
Good.
So if that's all you got, it looks like some of you guys have barely that. So hopefully you guys come tomorrow ready. Get some caffeine or whatever the hell, something.
I don't understand this part. You guys didn't make that.
I'm stopping your recording.
So for
Oh, you want me to stop it?
sure. For